the next week and a half, I'd say, just taking you to the end of the marking period. I'm not sure if you're aware, but next Friday is the end of the marking period. Does that come as a surprise to anybody? Okay, good. So we now have 4 marking periods instead of 2 semesters like we have run in the last, I don't know, 7 years probably. What that means is that you have a test in here next Thursday on chapter 3 that will be in this marking period. And pretty much everything then up until next Thursday will be a part of this marking period. And then anything after that will be part of the second marking period. Your quizzes yesterday were graded by 2 o'clock probably and placed into PowerSchool. So you should be able to look that up if you haven't already. Please check the edits that I made to your quiz. So I made comments, I made corrections, and then there is a grade that you should have in Google Classroom and also PowerSchool. Make sure those grades match up too. So there's a lot of like transferring grades from one program to another, and I have made a mistake or two. So please make sure you're double checking that the grade that I placed in Google Classroom is the same as what I placed in PowerSchool. If you have questions about that test, please ask. I mean, the ones that are here right now, you're in my room today and tomorrow. So like tomorrow when you come in, if you have questions, we can go over it together. If you're at home, send me an email and I can schedule a Zoom with you for after 2 o'clock, and I can go over questions with you on any pieces that you may not have understood from yesterday's quiz. So again, please make sure that you're like seeking me out, and I tried to reach out to a couple of you as well. Today, by the end of the day, make sure you turn in the linear programming part of the quiz. So that was 1 word problem. I treated it like a take-home quiz. You can use your notes, you can use the book, you can use any homework that we did, any recorded lessons that you want to refer to, but that is due by the end of the day. So please make sure that you do complete that. The goal is for that to be hopefully a pretty easy graded assignment. So it's not truly a quiz, but it is not just a homework assignment that I'm going to just quickly look at. So I will be grading it for accuracy as well. Any questions with that? So the second part of this chapter deals with matrices. We are still going to talk about solving equations because the whole bubble, chapter 3, is solving systems. So we're still going to work on solving systems, but we're going to look at like the matrices aspect of that as well. Tomorrow, if you have not like grabbed a calculator with you, make sure you bring a calculator either to class at home or bring a calculator to school because we will be using some applications of matrices in the calculator tomorrow and then Monday and Tuesday next week as well. I think that's it. Ms. Karp is going to start teaching, so I will be in the background walking around, peeking over your shoulder, but also taking notes on what she is doing. So she has been teaching my pre-algebra 2 classes for the last month, I'd say. Mm-hmm. And as a progression, she has to start taking on other classes. So she's now taking on you guys, and then eventually she'll have my honors trigger for calc class, but like kind of just working progression on the different levels of classes that I teach. I'll still be here though. And you can still reach out to me if you have questions. Or her. All right.
All right. So why don't you take out your note packet on your iPad, pull it up. We are on page 21. So like Mrs. Kane said, the last 3 sections for this chapter is on matrices. I think matrices are so cool. Hopefully everyone thinks so too. So what is a matrix? A matrix is a rectangular arrangement of numbers in rows and columns. So this looks like this. Here's an example of a matrix. We'll say we have 3, 1, 2, 0, -1, and 8. So this is what they look like. And there's rows. We have 2 rows here, and we have 3 columns. And that's the way we describe this matrix. So it's the dimensions. The way we say this matrix is a 2 by 3, because we have, you will take the rows, which we'll call M, and N columns, which here we have 3 columns. And so we read that, this is what it will look like. So it's M by N. And the way we read that is M by N. Not M times N here, that X just means by. Where M is the number of rows and N is the number of columns. So those are the rows. And there are the columns. So if we have 2 rows and 3 columns, this matrix is a 2 by 3. So let's look at this matrix. What would be the number in the second row, 3rd column? So 2 is the row. This would be the second row. So we know 2 means our rows. So we're going to go down to the second row. And 3 means a column. So we're going to go over to the 3rd. So our number in the second row, 3rd column would be that 8. So what about the 1st row, 2nd column? What number, Ella? 1. Yep. 1st row, 2nd column. What about 1st row, 3rd column? Jaden? 2. Yep. So that's how we can move our way through this matrix. So the elements are just the numbers in the matrix. Because any of those can also be a variable. It could be an expression in each of those positions. So we'll call them the elements. All right. So now we are going to add and subtract matrices. So in order to add or subtract 2 matrices, you're just simply going to add or subtract the corresponding elements. So you can add or subtract matrices only if they have the same dimensions. So when we say we can add or subtract the corresponding elements, they have to be in the same position. So let's look at these 2 matrices we have here. Now all of these letters can be numbers, they can be variables, they can be expressions. So in order to add them, just like I said, we're going to take the first row and first column. What number do we have there? In this matrix, A and E are in the same position in both of those matrices. So to add them, you just add the numbers or variables, whatever is there. And that's the same for subtracting. So down here, C is in the same position as G, and here we have a subtraction between them. So we're going to take C and subtract G, which we would put in that same position in the matrix where we're subtracting both of them. So that's how you add and subtract. It's very simple. It's taking whatever number or whatever is in that position and doing the operation that's in the middle of them. So now we're going to practice. We have this matrix. Oh, we have this matrix. Remember, let's look at the dimensions. The dimensions are rows by our columns. What would our dimension be for our first matrix here? How many rows and how many columns do we have? Alyssa?
2 by 2.
2 by 2, yeah, exactly. So this is a 2 by 2. And Alyssa, what about this one? What would the dimensions be for this matrix?
2 by
2 by 1, yep. Because our first numbers are rows, which we have 2. We have 1 column. Now, if you look back, the only way we can add or subtract these matrices is if they have the same dimensions. Do these have the same dimensions? No. So we can't subtract those. You would say don't have the same dimensions. So we can't subtract them. But let's look over to part B. What would our dimension be for our first matrix here? Rows by columns. Gabby Soul.
3 by 2.
3 by 2. And that's the same for our second matrix. We have 3 rows and 2 columns. So, and between them, we have an addition sign. So we are going to add them. So this would look like, let's take our number in our first row and first column in both. We have -2 plus 1. Now for first row, second column, we have 1 minus 4. So we're adding, but this is a negative. So we have 1 minus 4. And you would do the same for the rest of the matrix. You're adding the numbers in the same positions. So then what would this matrix equal? -2 plus 1 is -1. You can read off the rest of the matrix to me. I'll give you a second to solve. Ava R., were you able to get the rest of the matrix?
I think so.
Go ahead and read it off.
So how do you read it? Right?
Yep, we're gonna read it like a book. We're gonna go like that.
Okay, so I got -1, -3, -2, 12, 8, and 11.
Great. And that's how we're going to add them. Just adding the elements in the corresponding positions. Questions? Pretty easy. All right. Now we're going to multiply a matrix by a scalar. So a scalar is just this number out front. In matrix algebra, we call a real number a scalar. And we are going to multiply the scalar into the matrix just by taking that number and multiplying each number by our scalar. So we have 4 multiplied by -2 in our first position. We then have -2 times -1. And it's important to use parentheses here so you can see your negative signs. -2 times 1, -2 times 0, -2 times 2, -2 times 7. We did that oppositely. We're just multiplying every element by that number. So what are we going to get here when you multiply through? -2 times 4 will give us -8. Jaden, did you go through and multiply by the scalar? Go ahead. Sorry.
Next one's -2. Oh, sorry, I went down.
Okay.
Next one's +2. And then the next one's -2. And then it's 0, then -4, and then -14.
So whenever you have a number out front, you're just multiplying every number by that scalar, by that number that's out front. And that's it. So now we have two different things we're doing in part B here. We have this 4 in front of the matrix, and then we're adding. So before we can go and add, we need to multiply this 4 into the matrix. So you're going to go through and multiply each number by that 4. And nothing's happening to this second matrix. So I'm just going to rewrite that. And once you multiply that every element by 4, then you add those matrices. So I'll give you a second to multiply the scalar through and add those 2 matrices. Brooke, do you want to tell me what you got in the matrix when you multiplied it by the 4?
-8, -32, 20, 0.
And then when you added the 2 matrices, what did you get?
-11, -24, 26, and then -5.
Good. And that's it. That's your answer, Jaden.
Sorry, so do you have to show that parenthesis with every time?
No, so I did it so that you're able to see what we're doing here, but I won't do that again. That's just for you to understand what we're doing.
Thanks.
You're welcome. Yep, when you just have a number out front, you just take and multiply it by everything. You don't have to show that step. You can just go through and multiply. All right. Questions so far? Cool. All right, we are going to move on. So now we're going to take it a step farther. Here, we have 3 different matrices. We also have this 3 being multiplied to this set of parentheses. So we need to remember PEMDAS here. And we see these parentheses. We have to take care of what's inside of those parentheses first before we go through and multiply that 3. So I'm going to keep that 3 out front. And inside, we're just adding these 2 matrices. So here, we are adding variables. This first element is 5x, and we are adding 3. We don't know what x is right now, so we're just going to leave it 5x plus 3. And you're going to do the same for the rest. Six times -5 is -30. And for our second row, second column, we have -4 minus y. And we're just going to leave this matrix on the right-hand side. We're not dealing with this yet. We want to get the left-hand side completely simplified first. So now that we have this graph, yes.
Wouldn't the one in the corner be 1?
Yep. Good catch. Thank you. Easy mistake to make. Now we have our scalar out front. What are we going to do with this 3 when it's in front of the matrix? Be the n.
You multiply it by each of the elements.
Yeah, exactly. We're going to go through and multiply each element by that 3. So here, we have 3 multiplied by 5x plus 3. That would give us 15x plus 9. Because you're multiplying that 3 to each of them. So go through and multiply that scalar through your matrix. Lacey, do you want to tell me what you got when you multiplied your 3 through?
I got 15x plus 9, 15, 33.
So that's my bad. I put a 30 there. Brooke caught my mistake. We're just adding.
So 3 and then -12, -3y.
Good. And I'm just going to rewrite this matrix we have here on the left, on the right. So now we have an equal sign between these. Now each expression or number that is in each position, we are going to take each of these as separate equations. So we have this 15x plus 9, and that is going to equal -21. So now we can see that we have 4 different things equal. We have 15 equal to 15, good. 3 equal to 3. And then we also have this -12 minus 3y equal to what? What is that equal to? Jana?
24.
-24, yeah.
Oh, sorry.
You're good. I knew what you were talking about. And so this is asking us to solve for x and y. We have 2 different equations. Now we can just go through and solve for x and y. So go through. I'll give you a minute to solve for those variables. So when we're solving for x here, we'll subtract our 9 over. That gives us 15x equals negative 30. Ava R, what did you get for x?
X equals negative.
Good. And what about y? What did we get for y here? Drop? 4. 4. So we add the 12 over. Divide by negative 3 on both sides. Yeah, we get y equals 4. So that is what number we would plug in for y and x in order to get this expression and number equal to one another. So you could look, if you plug negative 2 in, that'd give you negative 10 plus 3. Oh, we're down here, my bad. We have negative 30 plus 9, which is negative 21. And same thing here, when you plug that 4 in, get negative 12 minus 12, negative 24. So that is what makes your matrices equal to one another. Questions? Bro.
Can you just write them as x equals negative 2? Or you write them as
This is just having x equals should be fine. You don't need to write it as a point.
Does anybody know why it would not be written as a point?
Is it because we don't have to graph it? Or what if we want to graph?
Correct, it wouldn't be on a graph. This isn't two lines that are intersecting at a point. So when you have two lines and they intersect at a point, then you would write it as an ordered pair. But those are just two random x and y values that are in a matrix. So they're not correlating with a line.
All right. Now we are going to do some more practice. That's weird. Okay. So here you have two matrices. Those are just lines. And you have a subtraction symbol in the middle. So you are going to subtract each number in the corresponding positions. And for B, for 2, you are going to multiply by that scalar. So I will give you a second to go through and solve those matrices. Julia, do you want to tell me what you got for number 1?
I got negative 9, 2, negative 8, negative 4.
Good. Because you have that minus and negative. Good. And for 2, when you're multiplying by the scalar, Alyssa, do you want to tell me what you got when you multiplied through?
I got 3, negative 9, 6, negative 12, negative 6, negative 27, 18, and 0.
Good. Questions on those two? Pretty straightforward. And then there is a number 3 to this. And this is just like that last problem we did. So what would our first step be here? If we have this scalar out front and then we have 2 matrices inside parentheses, what should we do first? Ella? Add, yeah. You want to add those matrices inside first. So leave that scalar out front. I will give you a second to go through this problem if you have not already started. Cody, do you want to tell me what you got when you added these matrices?
Negative 3x plus 9, and then negative 5, then negative 1, and then y plus 3.
Good. And I'm just going to rewrite that matrix. What's the next step you have to take here? Ava M.
You could take the number in front.
Mhm.
Figure what it's called.
Scalar. Yeah, and multiply through. So do you want to tell me what you got?
I got 6x minus 18, 10, 2, and then negative 2y minus 6.
Awesome. And we know that is equal to this matrix on the right. So what 2 equations did you make here when you were trying to solve for x and y? Ava R.
I made 6x minus 18 plus
Good. And then when you solved through, what did you get for x?
5. X equals
Good. Those 2 made them equal to one another. And what about for y? What 2 things are we going to set equal? Jaden?
It's going to be negative 2y minus 6 equals negative.
Good. And then what did you get for y? So those are what numbers you would have to plug in for x and y to get those matrices to be equal, to get those elements equal to one another. So that's it. I think it's kind of cool. I like matrices. So those are all the notes I have for you today. Your homework is in the book. There's about 7 minutes left. We could get started on it.
So if you go to Google Classroom and tap on those 3 arrows at the top right of Google Classroom. So when you get there, there's those 3 like triangle arrows at the top right. You click on them and go down to where it says, sorry, I'm looking over your shoulder. Class resources. It's going to be all the way at the bottom. If you click on that, and then click digital tools. So you're looking for class resources in my Google Classroom. Click on digital tools. The PDF of the book is in the digital tools. Julia emailed me about that last week. I think you must have maybe had a study hall or something and you wanted to get your math homework done. Now, it takes a little bit to download, and I would strongly suggest maybe placing it in Google Drive so that you have it, especially when you're in school and if you have time in school to get homework done. But I put it up on my iPad yesterday, and it takes about a minute or two to download. But that would be where you could quickly find your homework. And once it's like, I don't know, put it in Notability, download it in Google Drive, then you'll have it when you're in school to reference. And it will not take as long to download the next time around. But did anybody know that it was there? Yes.
Mhm.
You might have your book with you too. I don't know if you're carrying your book with you or not. Good luck, Terry. And if you want to pull up this screen just to remind them what the homework is, you guys should be at the front of the lesson.
Down here.
The class is over at 8:05. Again, unfortunately, that thing takes a while to download. 1,000-page PDF. Anyone have questions?
For the students at home, you can go ahead and start the homework, but that is all I have for today. So you are free to go. Have a good day.
Oh, yeah. Yes. And that's because it's counting like the first, whatever page. Yes. That are like information about each chapter. So yeah, the page number up there is 191. On your PDF, it's not going to be the same because the PDF is counting the first 20-some pages of information about each chapter. So you'll have to like scroll down till you find the correct page 191. Here you go. There you go. Oh man, Jocelyn, it's still working.
At least once it's downloaded, then you have it.
Success.